my dear students. Today topic is potential energy of a spring. We will study that Hooke's law and all. That's in solid chapter. From that application only we are using here potential energy of a spring. What is meant by Hooke's law? Restoring force. Restoring force developed in the spring. That means if you are pressing from one side, pushing from one side, it will create a force. That is restoring force. Restoring force developed in the spring is directly proportional to the displacement x. Displacement x, that is opposite to the displacement. That x is opposite to the force. Okay, we can take that F proportional to restoring force is directly proportional to the displacement. That is force and displacement is in opposite. That's why we are using minus sign, minus x. Then instead of this minus, we can use that is equal to, then we have to use one constant, that is minus kx. F is equal to minus kx. K means it is a spring constant. Spring constant. K means spring constant. X is the displacement. F means that's a force. This we have considered two spring. First case here x is equal to 0. There is no displacement. That means we are using massless spring. Okay. That's here. Next one is here x. That's we are using that mass. That time it will elastic. It displacement. It moves little bit. That's why we are using here x. First x is equal to 0. Again displacement. It will. We are using that mass. That time it will move. That displacement is x. Then we know that our work done is equation. Work done is equal to dW is equal to F dx. F dx means here displacement distance, that is dx, small distance. Then integration we can do, that is work done we can calculate. W is equal to integral from first case x is equal to 0. Second case x is equal to up to 0 to again distance, that is x, 0 to x. Then F dx. F dx. Then W is equal to F, we know that F is equal to minus kx. Then instead of that we can use 0 to x minus kx dx. K is a constant, we can take outside, minus k we can take outside. Then integral x dx. Then integral x dx, integral 0 to x dx. Then we know that is this integration of x raised to n plus 1 divided by n plus 1. Okay, n means here x raised to n plus 1, x raised to n plus 1 divided by n plus 1. Here is n means 1, nothing is there, that means 1. Then x raised to n, 1 plus 1, that is 2, 2 by n plus 1, that is 1 plus 1, 2. Then we get the answer x square divided by 2. We will study in maths. Integration of x dx, that is x square divided by 2. Then we have to substitute this limit, that is 0 to x. Then lower limit 0, upper limit is x. How to substitute this? First we have to substitute this x. Instead of this x, we have to substitute same thing. Then x square by 2 we will get. Then next minus this lower limit, that is 0. Instead of x square, we have to substitute 0 square divided by 2. 0 square divided by 2, that's 0 only. Here we get the answer x square divided by 2 we can use. X square by 2. Then we get that is minus k into x square by 2. Kx half. Answer is work done is equal to minus we can avoid. Then k half k x square. This work done means that is the potential energy. This work done means that is a potential energy. Then potential energy of a spring. Potential energy of a spring is equal to half kx square. Half kx. Spring force is conservative force. Then spring is displaced from initial to final position, again final to initial position. It will move from initial first to last, again last to first. Then we can write total work done is equal to Then integral from where to where? That is initial to final, again initial. Xi to xi we can write f dx. F means that is we know that f is equal to minus kx. Then minus k we can take outside. Then xi to xi x dx. Then we know that what is the integration of x dx? Already I told, that is x square divided by 2. Then we can write then minus k into x square divided by 2, lower limit xi, final limit xi. Then we can substitute this minus k into, this one is, instead of this x we can use xi. Then xi square divided by 2 minus xi square divided by 2, lower limit. Then minus k we can substitute. Minus k we can multiply this. Then we get the answer minus k into xi square divided by 2 plus minus k into xi square divided by 2. That means one term is positive, one term is negative. It is cancelled. That means total work done. Total work done W is equal to 0. Total work done is W is equal to 0 means there is no work. It is a conservative force. Then we can prove that spring force is a conservative force. Thank you. Tomorrow we will discuss on the topic collision in 2 dimensions.